Hey everyone, and welcome back to this class, Artificial Intelligence, Reinforcement Learning in Python. In this lecture, I want to discuss how to approach being hands-on and doing the exercises in this course, and specifically in this section. This section is all about Bandit methods. One very important concept for you to understand is that we're going to introduce several different algorithms in this section, but they are all used for solving the exact same problem. To see what I mean by this, let's recap what this means in supervised learning. In supervised learning, we are interested in implementing the algorithm we just learned about. The main outline is always the same, no matter what supervised learning algorithm we're implementing. The main steps are as follows. Step 1, load in the data. Step 2, instantiate your model. Step 3, train your model. And Step 4, evaluate your model. Your job as the implementer of the algorithm is to write up the fit and predict functions. This is the case for all supervised learning algorithms. In other words, you might want to think of this as a fill-in-the-blanks type of task. Steps 1 to 4 are boilerplate, meaning that no matter what algorithm you're implementing, you still have to do these things. As you can see, this same method would apply whether you're learning about naive Bayes, decision trees, or neural networks. The algorithm changes, but the layout stays the same. In this course, since we're not doing supervised learning, our layout will be different. But that doesn't mean there isn't still a pattern to be followed. I want to make it clear that in this course, the design of the script, and hence the layout, is part of your homework. This is not the type of course where you're going to fill in the blanks with 1 or 2 lines of code. We'll go over a rough outline, but generally speaking, you should have a pretty good idea of what this will look like in your head and why it's this way. To start, we're going to implement some actual casino machines. Now obviously, casino machines is just an analogy for actual real-life applications, such as serving advertisements you hope your users will click on, or showing different designs to see which one will keep users on your site for the longest time, and so forth. So just like a real slot machine, you want to be able to pull its arm. In other words, maybe have a pull function for your slot machine object. Of course, this should return a sample from the true distribution for wherever your samples are coming from. Now you have to remember that this is just a simulation. In real life, you're hooking this up to your ad-serving application, which has millions of users clicking on ads. I assume that most students taking this course don't have access to such applications, and even if you did, it's probably not the place to test something you just learned. Main point is, remember that you're writing a simulation of a real-life application and sampling from a real-life distribution in which you do not know the actual true distribution. But since this is a simulation, in this case you do know the true distribution. You're just pretending that you don't. The rest of your job is, of course, to actually implement the explore-exploit algorithm you learned about in this course to play the correct slot machine at each moment in time. In each iteration of this loop, once you've collected data from playing a slot machine, you're going to update your model's parameters. Once the loop is done, you'll want to print out useful information, such as the average reward over time and which slot machine your algorithm discovered is best. Of course, you'll want to compare that with the slot machine which is actually best to see if your algorithm learned the right answer.